Hello everyone, how was your exam? Please let me know in the comment. Good afternoon, Sridevi. Mola Reddy Singh, okay, good afternoon, Harshvardhan. So how was your exam? Let me know in the comment section below. Okay, and today I am going to solve the paper, not entire paper obviously. I will be basically discussing the MCQs and all the fill in the blanks and numericals from your Karnataka South. Okay, so let me know in the comment how was the paper. Good afternoon, Priyanka. It was easy. Sridevi saying, Haripriya is saying not very good, not very bad. That is fine. So many derivation. Muller Reddy is saying so many derivation. Derivations are good, no? It is scoring. It went well. Very good. Tough. Nandan is saying tough. Nandan, from where are you giving the paper? Let me know in the comment also that I am from this district, because the paper that I got from Bangalore South is relatively easy, not super easy, not super difficult. Some numericals are tricky, otherwise common questions came. In derivations, one unexpected derivation came, but okay, it is manageable and answerable. Okay, and if not a single question that came are out of my fixed question. So fixed question paper, if you have studied all the question, I know in one day it is very difficult to complete entire fixed question. So worry not, we will be completing all those questions I gave you in the fixed question section, and we will modify it a little bit based on the analysis of your all the papers. When we receive all the papers from all the district, we will college all the question papers, and I will decide on what are the important questions. Okay, so let's see the MCQs first. The expression for electric field at a point. Those who have given some other district paper, check if the questions are common or not. The expression for electric field at a point due to infinite line charge is given by E equals to lambda by 2 pi epsilon naught r. Okay, so if you are using 4 pi, you have to use a 2 over here, otherwise it will be lambda by 2 epsilon naught, and it is proportional to 1 upon r. So this is the correct answer. Next question, when a conductor, also by the way, those who have biology, there is a live class at 4 o'clock for all the bio students, right? So don't forget to attend that as well. When a conductor having a cavity is placed in an electrostatic field, the electric field inside the cavity is 0. This is called dielectric breakdown, electrostatic earthing, electrostatic shielding. It is called electrostatic shielding, not electrostatic polarization. Okay. Next, yes, I am from Bidar. Okay, MCQ was easy, sir. Lost in MCQ. Uttar Kannada, someone is saying, Nandan is saying Uttar Kannada. Mulla Reddy is saying part C. Everyone cooked the paper, but the paper cooked me. MCQ is difficult. Don't worry, those who have a slight difficult paper, it is good to have a little difficult in pre-board, so that you get little serious and study for your board exam. Okay, that is my opinion, and if you work hard, you should get out in your board exam if you start today. Okay, so as the temperature decreases, the resistivity of metals, temperature decreases means resistivity of metals decreases, semiconductors increases. Okay, easy question. All of the questions are very, very common. A galvanometer can be converted into a voltmeter by connecting what? High resistance in series. Okay, I am not taking the answers from you right now, because I am a little bit in a hurry, because obviously after my live there is a bio lecture, so that's why I am not taking. By the way, you feel free to post the answer in the chat. I will check it later. Okay, sir cooked, sir. Guppy fish, don't worry, let me know from which district you are from and what difficulties you faced. Mention in the comment. Okay, so I will try to address that in my future videos. Okay, don't worry. So a galvanometer has high resistance in series, can be converted into a voltmeter, right? Pick out the correct statement about bar magnets among the following. A freely suspended bar magnet points in the east-west direction. A freely suspended bar magnet points in the north-south direction. Okay, a freely suspended bar magnet points in the north-south direction. Poles of the bar magnet can be separated. No, it cannot be separated. The magnetic field lines present around the bar magnet are discontinuous. They are continuous curves. That is the difference between electric field and magnetic field, right? Next, Lenz's law signifies the law of conservation of charge, mass, energy. Charge and mass, it is energy. Now, not charge, not mass, it is conservation of energy. Lenz's law signifies the conservation of energy. Whereas Kirchhoff's laws, there are in one case it is charge, in one case it is energy. The power factor cos phi equals to 0. This is a very interesting question. Answer this question. Question number 7. The power factor cos phi equals to 0 in an AC circuit containing only inductor, a capacitor and a resistor in series, an inductor and resistor in series, only resistor. So the student from whom I have taken this paper, okay, he marked it incorrect. He marked it incorrect. So that's why I am giving you the answer. Komal Kaushik is saying 7D and remaining students are saying A. So which one, A or D? Okay, Nagaraj is saying A, Pratik is saying D. Okay, good Guppy Fish, good. Then that is very good. If you cook the paper, then it is very good. You should not get cooked by the paper. So only inductor, okay, cos phi equals to 0 is the lowest possible value. Cos phi for resistor, that is power factor for resistor is 1. Only resistor it is 1. When you mix capacitor and resistor, inductor and resistor, it is somewhere between 0 and 1. Okay, it is less than 1. Only resistor and in resonance, you get power factor equals to 1. All the other cases power factor is between 0 and 1. For only inductor or only capacitor, it can be, same question can be asked in your board exam and they change only capacitor, then you forget that sir told me only inductor, but here they have not given the inductor option at all. So what to do? So remember that only inductor or only capacitor can have power factor equals to 0. Resistor will have power factor, maximum power factor, that is equals to 1. Maximum value of power factor is 1 and that is possible in two cases, when the circuit consists of only resistor or the circuit is in resonance. These two cases power factor will be 1. Next, the student from which I have taken the paper, he also marked only resistor. That's why I given the answer, and you have some confusion among you, so that's why I clarified it. So don't make this mistake in future. Next, displacement current is the current due to time varying magnetic field, charges moving through the conducting wire, charges moving with the constant speed, time varying electric field. This is easy. This question is easy. Sir, thank you again. All because of you, I will be able to score more than 61 in physics preparation 1. Sure shot was very helpful, sir. It's me, Extreme. Thank you, Extreme. Thank you too for trusting me. No. Vlogs, D is not the answer. Power factor cos phi 0 is for only inductor and only capacitor. Power factor equals to 1 is for resistor. Okay, power factor itself, cos phi, not phi, cos phi. Okay, here it is cos phi is given, not phi. If it is phi equals to 0, then only resistor. Here it is given cos phi equals to 0. So there is a slight difference between cos phi and phi. So if cos phi equals to 0, what is the phase difference? Phase angle is 90 degrees. Phase angle is 90 degrees. So angle between voltage and current, is 90 degrees, not 0 degrees. The angle is 90 degrees. Cos phi is 0, not phi equals to 0. So remember this, here it is given cos phi, not phi only. Okay, power factor is cos phi, not phi. If phi equals to 0 is given, then only resistor is correct. But if it is cos phi equals to 0, that means the angle is pi by 2, and if the angle is pi by 2, the either current is leading or lagging. It can be leading, it can be lagging. In both cases, okay, both cases the angle is 90 degrees. So this is for inductor and this is for capacitor. For only capacitor, current leads, and for only inductor, current lags. But angle between both cases is pi by 2. Okay, so this is the reason. Okay, cos phi 0, remember this for a fact that cos phi 0 means phi is pi by 2. That means it will be either only inductor or only capacitor, not option D. Now this question is option D. Yes, those who are saying this is option D, yes, this is option D. Rudramurthy Singh, out of out. Congratulations, Rudramurthy. Thank you for trusting me. Next, this question is very interesting again. The graph representing the variation of angle of deviation delta with the angle of incidence I for a triangular prism is. So this is one angle, this is second case, this is third case, this is fourth case. There was some typing error in your paper ABCD. Now based on the college that you are appearing, the teachers have changes the option. So I have taken ABCD based on the first four. Okay, that's how it was instructed in this college. So that's how I have taken this order. It might be different for you because ABCD there was some mistype. Those who have appeared from Bangalore South, they know that. So option A and B both are given here, and C and D both are given here. Okay, A and C are given over here, and B and D given in the third image. Okay, so there was some typing issue with this image. Okay, but the correct answer is this one. The graph will be this one. Okay. Yes, Yashru Princess, what is your question? It will be C. Okay, it will be C, not B, not A, neither D, only C. Okay, this is the graph of delta versus I. This graph is given in your textbook. Even in my some of my lectures also I have discussed this image. So if you have followed my lectures, this you should know this is the correct answer. Okay, now question number 10. When light passes through narrow holes, it turns around corners and enters shadow region. This effect is called refraction of light, diffraction of light, interference of light, polarization of light. When light passes through narrow holes, it turns around the corners and enters shadow region. So what is the meaning of this? Suppose we have a hole, small hole, and you have a light source over here, a coherent source of light, and you have a screen. So according to the principle of rectilinear propagation of light, you should get a bright spot over here, and remaining portion should be shadow. Okay, these regions and this region should be shadow. But we get what we get, we do not get it like that, we get it like this. And we get some light in the shadow region as well. What is this property is called? This is called 10B, diffraction of light. Yes, 10B is correct. Sneha, free studies, you have 1 day break. That does not mean that you have time to play Free Fire. Okay, you can play Free Fire after your pre-boards are over for 1 day, then you can come back and study again. Okay, if unpolarized light of intensity I naught is passed through a Polaroid, the intensity of emergent light is. This is also very interesting. Try to answer this. I have those who followed my KCET lectures. I discussed in my KCET lectures, if unpolarized light of intensity I naught is passed through a Polaroid, the intensity of emergent light is. Yes, Rudramurthy, I will continue. Soon after your pre-boards are over, we will start our marathons, all subjects. Sir, biology marathon is enough to score 50. Is it pakka question? Yes, Yashu, Princess, if you follow ma'am from the beginning, if you follow the marathon, if you follow the live lecture that is coming today, and also the fixed question, definitely 50, you will get 60 pakka. Okay, that is guaranteed. So what is the answer for this? Answer this question. Option A. Yes, A. I naught by 2. Okay, it is I naught by 2. Single Polaroid. Single Polaroid means only one Polaroid is there. So when the light passes through this, okay, I naught, it will be I naught by 2. Okay, it will be I naught by 2. Next, question number 12. In the following table, the column 1 is the list of types of electron emission, and the column 2 is the modes of energy supplied for the process. Identify the correct match. Now here, as I mentioned, always the trick is try to find one unique match, and if you can get that unique match, most of the cases it will be correct answer. Okay, now you can I discussed this question yesterday also in my live, not exactly in this format, but there was only thermoionic emission, but I mentioned it. Thermoionic emission is heat energy, okay, field emission is electric field, and photoelectric emission is light energy. Now if you see that option 3 is matching with Q, and that has only one correct option. Okay, option 3 is matching with Q is only once, that means definitely option D will be correct. So even if you don't know what is thermoionic emission, if you don't know electric field emission, if you know photoelectric emission is due to light energy, photo represents light, that means if you can do this matching, you should get the correct answer. Okay, remaining will automatically fall in place. So every match the following question generally have this kind of trick. So if you find that correct match, one single correct match, you should be able to answer the question. In alpha particle scattering experiment, an alpha particle rebounds back along the same path. Then B is impact parameter, theta is angle of scattering. What will be the correct answer? Sir, will you discuss all part or only numerical? I will go through, I will show you the questions and then I will discuss the numericals, okay? That is the main thing. I will not discuss long form answers, that is already discussed multiple times. Tomorrow, anyway, physics exam is over. So if required, I may discuss important questions again if you are interested for pre-board 2. But otherwise, no, long form questions I am not going to discuss. But yes, 2-3 marker, wherever there is a numerical, I will solve them. Okay, and I will need your help. Take out your calculators, because the questions that came they require calculators. Okay, without calculator it is difficult to solve. Now, in alpha particle scattering experiment, an alpha particle rebounds back along the same path. Then the impact parameter and theta. What is the answer? Rai Ganesh is saying D. So let's see what is option D. No, option D is incorrect. Rai Ganesh, sir, what you said same question came in preparatory, sir. Thank you. Welcome, JE aspirant. Sanjana, how boards evaluates it? I don't understand your question, Sanjana. Option A, yes, option A is correct. Option A is correct. So when a charged particle is hitting the nucleus, okay, the B should be 0. The B should be 0. Direct encounter, and it is coming back straight away. So only if the impact parameter is 0, it will rebound straight away, and the angle will be 180 degrees. Angle will be 180 degrees. So B equals to 0 and theta equals to 180 degrees. This is a hot question. Isotones are the nuclei having isotones. Very common in chemistry, you have studied in chemistry. Sir, is it necessary to attend extra questions in final exam? If possible, yes. If possible, at least one question in each section, 2 marker section, 3 marker section. If possible, 1 extra numerical. That is my recommendation. Derivations, you can skip. Okay, some toppers, they get a lot of time, they practice a lot, they study a lot, they get time to write 1 extra derivation also, but derivation 5 marker not required, but extra 1 2 marker, extra 1 3 marker, and extra numerical if possible. That is my recommendation. Sir, for 8, why not A? Cause magnetic field varies, electric field also vary. Yes, but magnetic field varies, does not produce electricity. Okay, current. To produce current, you need to produce displacement current, you need varying electric field. Electric field changes gives rise to displacement current. Magnetic field variation does not give displacement current. Displacement current's origin is, if you remember, ID was given by epsilon naught dE by dt. Okay, for your class, this is the correct expression. So ID or displacement current was coming from the variation of electric field, not because of magnetic field. Okay, so that's why it is due to the variation of electric field, not magnetic. Magnetic field variation does not produce current. Okay, option C. Same number of protons. No. Isotones. Isotope is same number of protons. Isotope is same number of protons. Isobar, same number of nucleon. This is isobar. And this is isotope. Okay, different number of protons, all elements have different number of protons, so definitely this is not a correct answer. So same number of neutron are called isotones. Isotones, same number of neutrons. You have studied in chemistry, right? If not, but as magnetic field varying, do you tell there is no displacement current? Maybe not. Varying magnetic field will produce electric field, but that electric field, whether it will produce current or not, that is not guaranteed. Okay, but yes, varying electric field will definitely produce current. That is for sure. Okay, that's why. And displacement current alone cannot exist. It has to be synced with the conduction current. So if you remember the experiment where Maxwell did thought experiment, it is called thought experiment because he did not do it using something in reality. So he used a capacitor plates, okay, parallel plate capacitor, and he said there is a gap between capacitor plates, so how can current be passing through this gap? Okay, that was his question. He said that okay, the battery is there, so current can pass through the conductor. Okay, so how can current, where there is no connection, how can current be passing through this gap? So he said that because inside the capacitor plate there is something called displacement current, which is basically helping the current to move forward. Okay, and there is a conduction current. Conduction current is actually helping to change the electric field, and that electric field is basically helping to conduct the current. No, magnetic field, varying magnetic field can produce constant electric field also, and constant electric field will not produce displacement current. Okay, that is for sure. So that is why it was concluded that only varying electric field will produce displacement current, not varying magnetic field. Okay, an example of trivalent impurity. Example of trivalent impurity. Yes sir, many MCQs are correct. How much marks is good in preparatory, Ganesh? You can so anything beyond 50 plus is good. Okay, in my opinion, if you are scoring 60 plus right now, then you should attempt for 70 in your board exam. If you are scoring 50 plus now, then also you can get 70 in your board exam. Okay, but anything below 50, you have to work really hard. Okay, 50 plus in my opinion is a good marks, right? So what is a trivalent impurity? What is a trivalent impurity? So many questions, let me answer it one by one. Practically there is displacement current where magnetic field is varying. I am not sure, Sharag. You can do an experiment and prove that, then you might get some recognition. Okay. Sir, how much marks is good in preparatory? I already answered that. 5, fill in the blanks. Yes, fill in the blanks I will do. Okay, fill in the blanks I will do. So, example of trivalent impurity: arsenic is pentavalent, boron is trivalent, antimony pentavalent, phosphorus is also pentavalent. Okay, so only trivalent is boron. Now fill in the blanks. Fill in the blanks. Get ready. Magnetic susceptibility of a ferromagnetic material is AC generator, concave, negative, matter, transformer, positive. So for susceptibility for ferromagnetic, it is positive. Okay, it is very greater than 1. For paramagnetic also it is positive, but it's small value. For diamagnetic it is negative. Okay. Mechanical energy is converted into electrical energy. Mechanical energy is converted into electrical energy for AC generator. For AC generator. Okay. The device which works on the principle of mutual induction. Device which works on the principle of mutual induction, transformer. Okay. Reflecting telescopes use dash mirrors. In objectives only one mirror is there, that is concave, so concave. Okay, during interaction of radiation with dash, radiation exhibits particle nature. So out of all the option, only matter is there. So matter, on the interaction with matter, radiation behaves as particles. Okay, so this is the correct fill in the blanks. Now let's move on to the I will see the questions one by one. State and explain Coulomb's law in electrostatic, common question. Multiple times I have discussed what is the equipotential surface. Draw the equipotential surface for a point charge. It will be spherical. You have to draw some concentric spheres. If you use a compass, that is better. Okay, equipotential surface also I have discussed multiple times. Next, mention any two limitations of Ohm's law. Again, common question. Okay. Next is, when the force on a charged particle moving in an uniform magnetic field, A maximum and 0. So when the force acting on a charged particle moving in a uniform magnetic field, what is the force on a charged particle? QVB cos theta. Okay, so QVB, sorry, not cos theta, sin theta, what I am writing, QVB sin theta. Okay, this is the force acting on a charged particle. Now force is maximum when the angle theta is such that sin theta is 1. So basically sin theta is 1, force is maximum. And when it is 0, when sin theta is 0, that means theta equals to, at theta equals to 90 degrees, force is maximum, and theta equals to 0 degree, force is minimum. Okay, because they have mentioned moving particle, so you cannot take V equals to 0. Okay, because they have mentioned moving in a uniform magnetic field, that means V is not equals to 0. So it you have to use sin theta for maximum and 0 for 0. Otherwise you can you could have take V is equal to 0, but anyway, because they have mentioned moving particle, so you have to mention theta equals to 0, not V equals to 0. Okay, so that is one thing that you have to memorize. Okay, now next, the magnetic flux linked with the coil changes from 5 into 10 to the power of minus 3 Weber to 3 into 10 to the power of minus 3 Weber in 0.01 second. Calculate the magnitude of the induced EMF in the coil. So induced EMF is given by d phi by dt, magnitude wise, right? Magnitude of epsilon is given by d phi by dt. Okay, so it changes from 5 into 10 to the power of minus 3 to 3 into 10 to the power of minus 3. This is the change, d phi, and dt here it is given as 0.01. So we get 5 minus 3, 2 into 10 to the power of minus 3 divided by 10 to the power of minus 2, that is 0.2 volt. So correct answer for this, those who have answered it, it will be 0.2 volts. Okay, let's move on. Name the electromagnetic waves produced by accelerated motion of charges in conducting wires and hot bodies and molecules. Okay, accelerated motion of charges in conducting wires basically produce heat. Okay, hot bodies also produce heat. So infrared radiation. So infrared radiation, actually I think both cases it will be infrared radiation. I am not sure why they have given accelerated motion of charges in conducting wires. Conducting wires means they are producing heat energy, heat generally in infrared radiation. Okay, it can be other version as well, but hot bodies will always produce infrared, and in my opinion this will also be infrared. If you have any other answer, you can mention that in the comment. Hello Satyanarayan. I will go to numericals. Just a quick recap. Which of the expression is the nth orbit of electron in hydrogen atom, and explain the terms, very common. Name the majority and minority charge carriers in p-type semiconductors. I have discussed it. Write 3 basic properties of electric charge. Common question. Derive the expression for effective capacitance of 2 capacitors. I have done that. Using Ampere's circuital law, obtain the expression for magnetic field at a point due to an infinitely long state conductor. Even though I have not discussed it, this is a very easy question. State and explain Gauss's law in magnetism, give it significance. This is also very easy, I have given it in my fixed question. Derive the expression for energy stored in a current carrying inductor, easy question. Next, show the radius of curvature of a spherical mirror is equal to twice of this focal length. Again, very common, I have discussed it multiple times. Mention any 3 experimental results of photoelectric effect, common question. Calculate the binding energy of an alpha particle in mega electron volt in the following data. Mass of alpha particle is 4 into the 4.00 into 260 U. Mass of neutron is this. Mass of proton is this. Then what is the binding energy? Only the binding energy that you have to calculate, not binding energy per nucleon. So in helium, how many protons are there? The number of protons in helium is equals to 2. Number of neutrons in helium again is 2. Okay, 4 minus 2 again is 2. So what is the mass defect? Mass defect is given by mass of proton into number of proton. Okay, let me use this. Okay, number of protons plus mass of neutron into number of neutron minus the total mass of alpha particle. Okay, so you have to multiply these two. I am not doing the mathematics. If you are interested, you can do that. So 1.00782, you have to use the values properly, into 2 plus 1.008662 into 2 minus 4.0026. Now at the end, what you have to calculate? You have to calculate the binding energy. Binding energy is given by delta M into 931.5 mega electron volt. Okay, so this is the thing that you have to remember. If you multiply with 931.5, you will get the exact value. Clear? Now derive the expression for electric potential due to a point charge. Common question, I did it in the 30-minute review as well. Assuming the expression for drift velocity, derive the expression for conductivity. This was in a model paper. So model paper 1, they have given this question. Obtain the expression for force per unit length between two infinitely long straight parallel wires. Again, I have discussed this question and it was there in my fixed question. What is a wavefront? State Huygens principle using same, show that angle of incidence equals to angle of reflection in case of plane wavefront. Again, this question was there in my fixed question. Classify solids into conductors, insulator and semiconductors on the basis of band theory. What is a rectifier? So they have not given full wave and half wave rectifier in Bangalore South. They have given the other question that I said may be less important, but in some cases it will come, and it came in Bangalore South. Which property of a PN junction diode is used in rectification? Okay, so it basically allows the current to pass through in only one direction, it blocks in the other direction. That is the thing, that is the property is used in the rectification process. Now let's see the problems, numericals. 4 point charges, plus 6 nanocoulomb, minus 3 nanocoulomb, plus 6 nanocoulomb and plus 3 nanocoulomb are placed respectively at the corners A, B, C and D of a square ABCD of side 0.2 meter. So let's draw the diagram first. So whenever you see such questions, diagram is compulsory. Without diagram you will not get any marks. So we have a rectangle A, B, C, D. You can take it any order, does not matter. Okay, order does not matter, as long as you are taking them in circular order, that is fine. You should not take A, B, C, D, that is not correct. Okay, you have to take them in a circular order. Now it says that at A we have plus 6 nanocoulomb, at B we have minus 3 nanocoulomb, at C we have another plus 6 nanocoulomb, and at D we have plus 3 nanocoulomb. Now the question is very interesting. Even though it looks difficult, actually it is not. You have to join the corners. Okay, now you see that at the corner A and C we have plus 6 plus 6. So due to this plus 6, the electric field will be in this direction, that is EA. And due to this plus 6, the electric field will be in the opposite direction along the diagonal, and it will be EC. And both of them are plus 6. So what we can say, magnitude wise, we can say that EA magnitude wise is equals to EB. But they are in the opposite direction. Sorry, not EB, EC. They are in the opposite direction. Okay, they are in the opposite direction. So if they are in the opposite direction, so what is the net electric field along the diagonal AC? The net electric field along the diagonal AC is EA minus EC. Okay, both are in opposite direction, so that's why there is minus, and because the magnitude are same, so we will say that EAC is equals to 0. So the net effect of this one and this one, they are cancelling each other, so they basically do not exist, and we do not need to use these 6 nanocoulomb to calculate it. Now what is there then? What is left then? What is left is here is these two. Okay, this plus 3 will have an electric field in this direction, okay, ED, and this B will also have electric field in this direction. So for negative it is towards the charge, for positive it is away from the charge. So I always say that do not use the sign of the charges, only use the direction to calculate the electric field. If you use the sign, you will get confused and you will not be able to answer it. So always draw the diagram, analyze the diagram, and then realize what is the net direction. So net direction in this case is from D to B. So net direction is from D to B, so we have to calculate EDB. EDB is basically addition of ED plus EB, right? ED is also in this direction, EB is also in this direction, both for this point. For this is the center of the square, right? They ask you to calculate the magnitude and direction of resultant electric field at the center. Center means where the two diagonals meet, right? So at the center both electric fields are in the same direction, so they will be added. Now both magnitude of the charges are same. Both are having same charges 3. Now if this distance is smaller, this distance will also be smaller, right? So what we can write? We can write this as KQ by R square plus KQ by R square. Both of them will have same magnitude. Magnitude wise same, direction wise same, so they will be simply be added. So we get 2KQ by R square. Now we have to calculate the value of R. So R is, what is R? R is half of this diagonal dB. Okay, R is half of the diagonal dB. So what is the diagonal of a square? Diagonal of a square is A root 2. What is A over here? A is 0.2. So 0.2 by 2 into root 2, or it will be 0.1 root 2, or we can write this as root 2 into 10 to the power of minus 1. Do not calculate it. It might complicate your calculation. Okay, do not put the value of root 2 as 1.4141. That is not required because we have a square over here, so root 2 can be cancelled. Now we have to put the values. So 2 into K is 9 into 10 to the power of 9, and charge, any one charge you can take, only magnitude, so 3 into 10 to the power of minus 9. Okay, do not take negative sign. Divided by R square, that is root 2 square, that is 2, and 10 to the power of minus 1 square, that is 10 to the power of minus 2. Okay, so this is R. So R square will be 2 into 10 to the power of minus 2, right? Now you can cancel and you will see that the problem is very, very simple. 10 to the power of plus 9 minus 9 cancels. We have 27 divided by 10 to the power of minus 2. So 27 into 10 to the power of plus 2, that is 2700. And the unit will be Newton per Coulomb. The direction is from D to B. Okay, it will be from D to B. The direction is from D to B. Okay, or if you name the center as O, it is along OB, along OB. Okay, direction is also important because they have mentioned resultant electric field and the direction. Okay, so direction is also important. If you don't mention the direction, they will deduct 1 mark. Okay, I hope everyone got this answer. 237, faster. I am doing faster. Now this question is tricky. I will help you out how to solve it. Now, so here we have a circuit. Find the potential difference. Potential difference, not the current. Remember that. Potential difference across the resistor I3. Resistor 10 ohm, that is this current. If you can calculate I3, you can find the potential difference as well. So what is the potential difference? Potential difference across this, that is VB, is 10 I3. If we can calculate this value, we will get the answer. Okay, so now how to do that? First of all, current I1 is passing through this, that is current I1 is passing through 6 ohm, this 2 ohm and this 4 ohm as well. Why? Because remember that conservation of charges. So whatever current exits a battery, the same current should always come back to the battery, always. Okay, so here I1 current is coming out of the battery, so I1 current should also go back. Similarly, I2 current is coming out of this battery, then I2 current will also come out of this battery as well, go back to the battery as well. Now, so this 6 ohm, this 4 ohm and this 2 ohm. Do not ignore this 2 ohm. This is basically, you can consider as a series connection with this, right? So this 2 ohm, all of them have same current I1. So when you apply, first we will apply Kirchhoff's law in this loop. Okay, A, B, E, F, A. So first we will apply Kirchhoff's law in the loop A, B, E, F, A. Okay, so in this loop, what is the total voltage drop? So voltage drop due across this is 6I1. Voltage drop across this one is 10I3. Okay, 10I3, and voltage drop across this 4 ohm is 4I1, and voltage drop across this 2 ohm is 2I1, and that should be equals to the voltage that is connected, that is 4. Okay, now if you add everything, you will get 12I1 plus 10I3 equals to 4. If you divide both sides with 2, you will get 6I1 plus 5I3 equals to 2. This is equation number 1. Okay, now also one more equation you have to simplify, that is, at this junction current I1 is coming in, current I2 is coming in, right? This is I2, so I1 is coming from this side, I2 is coming in from that side, so both currents are incoming and only outgoing current is I3. So we can say that I3 is basically equals to I1 plus I2, and our target is to calculate I3. So what we will be doing, we will take I2 as I3 minus I1. Okay, so we will construct two equation and then solve for I3 directly. Okay, we will solve for I3 directly, that is the shortest method. Okay, now we will apply the same thing in this loop as well. So in this loop, I2 is passing through 6 ohm, so 6I2 plus 10I3 plus 4I2 plus there is 1 ohm over here, so 1I2 equals to the battery EMF, that is 2. Okay, now simplify this, we get 10 plus 1, 11I2 plus 10I3 equals to 2. Now obviously 11I2 we have to substitute with this value. So 11I3 minus I2 plus sorry, not I2, I1 plus 10I3 equals to 2, or minus 11I1 plus 21I3 equals to 2, right? Now we have to eliminate I1 from these two equations and calculate I3. So how to do that? This is equation number 2. So obviously what we have to do, we have to multiply equation number 1 with 11, and then we have to add it with equation number 2 with multiplying 6. Okay, so if you multiply 11 on both sides, you get 66I1 plus 55I3 equals to 22, and what you get, multiplying 6 minus 66I1 plus 126I3, and that is equals to 12, right? Add them, what you get? You get this cancels and you get 181I3 equals to 34. So I3 equals to 34 divided by 181. So this current we have calculated. Now we have to find the voltage drop. So voltage drop will be, voltage across 10 ohm will be 10I3, that is 340 divided by 181, and if you solve it, I think it will be coming around 1.88 volt. Okay, 1.88 volt. Now if you are not familiar with Kirchhoff's voltage law, I did a live some time back, you can go and check that out, right? Final answer of all the numericals. Saina, I don't know the answers. I am solving it along with you. Okay, I am solving it along with you. I have just checked the answer. I have checked the process, but I have not calculated the final answer. A series LCR circuit containing an inductor of 1.194 Henry. Now again, some weird values are given here. A capacitor of 35 microfarad and a series of and a resistor of 40 ohm is connected to an AC source of 200 volt and 50 hertz. Calculate the impedance and power factor. This is something new. Generally they ask phase difference. This time they have asked power factor. First we have to calculate the impedance. To calculate impedance, obviously first step is to calculate XL, 2 pi f into L. So 2 pi. Now someone take out your calculator and tell me the value. 50 into L is 0.194. Okay, tell me the value. What is this value? And XC equals to 1 by 2 pi FC, that is 1 by 2 pi into 50 into 35 into 10 to the power of minus 6, or 10 to the power of 6 divided by 100 into 35 into pi. Okay, so 100 will cancel. You will get 10 to the power of 4 divided by 35 pi. So that is 10 to the power of 4 means 10,000. Okay, 1, 2, 3, 4. 4 zeros divided by 35. So calculate these two values and tell me the answers. 60.9. Okay, let me take this as 61 ohm. And what about XC? XC impedance is 50, I think. Someone is saying 40. I got 26. 90.9. Okay, 91. If you don't cheat, if you don't make anything else, I think you will get around 61 and 91. Okay, the value seems right. Now, what is the impedance? Impedance will be square root of R square into XL plus XL minus XC whole square. Okay, so R square is 40 square plus 61 minus 91 whole square. Now there will be minus 30, does not matter minus 30 because there is a square involved, so you can write this as 40 square plus 30 square. Okay, 40 square plus 30 square is 50, square root of. Okay, 4 square plus 3 square, square root is 5, so 40 square plus 30 square, square root will be 50. So Z is coming out to be 50 ohm. So those who got 50 ohm are correct. Maybe if you take exact values, it might be slightly up and down, but 50 ohm seems correct. Now what about power factor? Power factor is given by cos phi, not tan phi or not tan inverse phi, and cos phi is given by R divided by Z. This is the direct formula. R divided by Z is direct formula. Otherwise you can calculate tan phi. From there you can take tan inverse, calculate phi, then reverse engineer to calculate cos phi, but that will be very long process. This is the shortcut formula for cos phi. For power factor, R is given here as 40 and Z we calculated 50, so it is 4 by 5. Okay, there is no dimension, no unit for power factor. Power factor is a dimensionless quantity. Okay, so power factor is 4 by 5, and as you see it is less than 1, so our answer is correct. Next question, last question. An objective of height 3 mm is placed at a distance 14 cm in front of a concave lens. So concave lens of focal length 21 cm. Concave lens of focal length 21 cm. Okay, and the distance here U is given as 14 cm. Okay, U always be negative, and for concave focal length will also be negative. Okay, find the position, nature and size of the image formed. So first of all, what is the formula? 1 by V minus 1 by U equals to 1 by F. This is the direct formula. No, we have not applied any sign over here as of now. So 1 by V equals to 1 by F plus 1 by U, or UF U plus F, or V equals to UF by U plus F. If you can remember, you can use this formula directly as well. Now we have to use the values with sign. So U is minus 14, F is minus 21. Minus 14, minus 21. So it will be top minus will cancel and bottom minus will be common. So minus 14 into 21 divided by 35. So 5, 2. So it will be minus 42 by 5. So it will be minus 8.4 centimeter. So object and image are in the same direction for a given lens. That means it's a virtual image. So position is 8.4 centimeter in the same direction as the object. Okay, in the same direction as the object, same side as the object. Next is size. Size will be to calculate size, you have to find the magnification. Magnification is given by V by U. So V by U, V is minus 8.4, U is minus 14. Okay, I don't think you can get a you can get. So 8.4 by 14, so it will be 7. First cancel with 2, 4.2, and it will be 0.6. So it will be 0.6 the magnification. So size of the object, size of the image will be magnification into height of the image object. Height of the image is so this is the HO. So 0.6 into 3, that is 1.8 millimeter. Okay, so size is, so this is V, size is 1.8 millimeter, and nature is virtual. Nature is erect and virtual. Now how I say this is erect? Because the magnification is positive. If magnification is positive, then it's a erect image. Yes. Hussein, there is no negative sign for lenses. Magnification, there is no negative sign for lenses. Negative sign is there for mirrors. So that's why students get confused. There is no negative sign for lenses. Negative sign is there for mirrors. For lenses, it is positive. Okay. 49.9 is fine. 1.245 is power factor approx. No, Hussein. Power factor cannot be greater than 1. Power factor greater than 1 means cos theta is greater than 1. Okay, if cos theta is greater than 1, that is not possible. The maximum value of cos theta is 1, minimum value is minus 1. So cos theta has to be between 1 and minus 1. So you have flipped it. You have done Z by R, not R by Z. Right, Hussein? Okay. Anyway, I have to conclude this live. You made small mistakes, but that can be corrected later on. Okay. Anyway, see you later, and let me know in the comment section of the main video later on how was your exam, and please don't forget to thumbs up, give this video a like. Also subscribe to our channel if you want more help for your upcoming board exam as well as KCET 2026. KCET 2026 dates are announced, so if you are not aware, there is a video available in our channel. Go and check that out, and I will be see you soon in a future video. Till then, bye.